Hello, so here we have the displacement time function of a particle where s of t is equal to t cubed minus 2t squared plus t, where t is more than or equal to 0. So t is time and s is displacement. So first we have to find v of t, which is the velocity time function. So first we know, as we know, the derivative of s of t, s prime of t, is equal to v of t. So we'll take the derivative of this function. So that would be 3t minus 4t plus 1. So that's a square. Okay, so from there, you can just plug that in right here. That is equal to 3t squared minus 4t plus 1. Okay, now we have to find a of t. Well, we know that s double prime of t is equal to f prime of, v prime of t, which is equal to a of t. And that is equal to 6t minus 4. 6t minus 4. Okay, so when is it at rest? Well, the term at rest, well, that means essentially when v of t is equal to 0. So let's take our v of t and set that to 0. So 0 equals 3t squared minus 4t plus 1. We can factor this. 0 equals 3t. We'll put a t here. And I believe that is, that should be minus 1. Minus 1, minus 1. Okay, so that is where t. So okay, wait, I'll do it this way. 3 with the zero product rule, 3t minus 1 can equal 0, or t minus 1 can equal 0. So in this case, t will equal 1/3. In this case, t will equal 1. Okay, so we know it's at rest at t equals 1/3 and t equals 1. Okay, so now let's solve for when is it moving backwards. Well, the particle is moving backwards when, I'll just erase this. Particle is moving backwards when v of t is less than 0. Okay, so, but before we plug this in and try to solve, let's take a look at our resting point. So we know this is a cubic function, and since a is positive, it's 1, it's going to look something like this, something around like this. And we know that this is t equals 1/3. This is t equals 1. So it must be moving backwards or in the negative direction between these 2 points. So we'll just say that it'll apply when t is more than 1/3 and less than 1. And this is not inclusive because we know that at these points v of t equals 0, and that's not, and 0 is not less than 0. So it's this point right here. And that's how you solve this kinematics question. Thank you.